Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us. Oop, looks like Mario ducked out right at the perfect second. We're going to give him another minute or two. Please stand by.
Do you hear me?
Yes, we can hear you. Welcome back, Mario.
Okay, sorry.
Okay, just evidence that we are live. We are indeed live, folks.
Okay. Yes, thanks for having me in this reactor series. It's very good, and thanks Rory to having this long series about LangChain4j. Really appreciate it. So I'm one of the LangChain4j committer. I'm the main creator of the agentic framework of LangChain4j. So I'm here today to speak about this. First of all, I always introduce my talk this way because lots of people ask me, are you seriously doing agentic AI in Java? Don't you know that the entire world is doing this stuff in Python? And my answer is that, look, I'm not a data scientist. What I do is taking models from, I don't create model. I take them from, I don't know, Hugging Face or the Olama repository, and I use them and I integrate them in enterprise-grade application that 90% of time are written in Java. So why not keeping writing in Java also the LLM integration part instead of doing this in Python with all the enterprise feature that you are probably missing. So I believe there is a strong reason to do this in Java, and in essence, yes, I'm super happy that your experiment works on your Jupyter notebook, but very likely we are not going to put this in production, and that's why it's nice to do this stuff in Java. Okay, so after this parenthesis, the story that I'm telling you today is a story in 4 stages. Is my path toward the creation and improvement of this agentic framework. I will start from the single AI services. You have heard a lot about this in the former meeting with Rory, so I will go very fast on this. And then I will introduce the agentic pattern, which are first the workflow-based, the deterministic one, when you orchestrate agents in indeed the deterministic way. And then we want to also leave the control of the orchestration to another LLM. So we want to give even more autonomy to our agentic system. And then we will reach the 4 stages when I realize that there is not really a one-size-fits-all pattern. So I refactored, reworked all my work to allow people to plug their own orchestration pattern implementation. Okay, so this is the story that I'm telling you today. What happened in reality and what is still happening. It's more similar like this. I'm of course doing a lot of rethinking, reworking, writing code or generating code sometimes nowadays, and then deleting it. So it's not a straightforward development process, mainly for 2 reasons. First, because usually I don't know what I'm doing while I'm doing it. So it's a lot of experimentation. And second, because the landscape is changing with an extreme speed. Everything is changing really fast, and it's like working and design your framework on the quicksand, and so it's a moving target, and you need to adapt very fast to this change of landscape while you're working. Okay, so as I said, it all starts with an AI service. I will go very fast on this because I believe that Rory explained all of this in very deep detail. So you start with a single LLM, then you need reasonable prompts to make the LLM to understand what you want, and then of course this thing is stateless in nature, so you need a chat memory to simulate a conversation, and then you need some tooling to let the LLM to do something useful, like accessing, reading, and writing a file system, or calling external REST API, for instance, to take the latest stock quotes or weather forecast and stuff like this. And then, of course, you need some data sources to implement the RAG pattern when you need it, and you need some guardrails to control both the input provided by the prompt provided by the user to avoid malicious attacks or prompt injection mostly, and also you want output guardrails to also control the output of the LLM to be sure that I don't know, it follows your company policies, for instance. These slides I changed it last month, but this slide is already old. One thing that we introduced with LangChain4j 1.12 is skills. So we also have skills now in this set of components that you need to, let's say, decorate an LLM and make it work with all the feature that we are used to have today. Okay, so this is the single AI service, but the idea is that you want to apply the divide et impera principle here. You don't want a single AI service to do very complex tasks. You want to split this task in smaller subtasks and have different agents that are specialized for each of these subtasks. And then, of course, when you do this, you need some orchestration between the different agents. So in essence, what I'm saying is that an agent and AI service are exactly the same thing, with the difference that an agent is not supposed to live in isolation. Is supposed to be part of a more complex agentic system. Is supposed to collaborate with other agents. So that's the thing, and this is also how it is implemented internally. In reality, in LangChain4j, an agent is just a tiny wrapper around an AI service that adds this layer that allows the agent to collaborate with the other agent, as we will see in the next part of this presentation. Okay, so I worked on this, started working on this stuff in the first half of last year. We introduced as an experimental module this LangChain4j agentic module in August for the first time, August 25, of course, with LangChain4j 1.3.0, which was the first release having this module. And as I said, now we have the 1.12 now, so we are moving quite fast. We are basically doing a release every month, or even less. So and as you see, there are lots of features, and this list of features is probably already a little bit outdated as well. So again, this agentic framework is all about creating a framework through which these different agents can collaborate. It's an orchestration framework among agents. And when I started working on this, the first thing that that introduced me to this domain, to this problem, was a paper produced by Anthropic and published in November 24, which, if you think about it, is 15, 16 months ago, but they seem 15 or 16 years. Times fly very fast in this domain. But anyway, that Anthropic paper was in reality pretty straightforward. It just applied to the agentic domain the pattern that you use probably from the very first day when you started programming in your life, right? So we just have a sequence of agent, and in the agentic domain, we can call this sequence of agent prompt chaining, because of course what you do is that the output of an agent in the chain becomes the input of a subsequent agent. Then we have a loop, meaning that you want a loop invoking the same agent again and again until a given condition is satisfied. And that this is also called reflection, because typically you want to do this to allow the agent to reflect on its own work and improve it up until a given condition, as I said. And then, of course, you may want to have different agents that are independent to be called in parallel. And finally, you may want to have some conditional invocation, or in essence, some routing to decide which of a set of agents has to be called given a specific condition. Okay. So in essence, these are the 4 patterns that I started implementing. But the very first thing that I did in reality was that I wanted to define, to allow my user to define the API of their own agentic system, okay? So I started in this very simple example, for instance, with these 3 agents. The first agent is a creative writer that takes in input a topic and generate a story about the topic. And then I have a first reviewer, an audience editor that edits the story for a specific audience. I have a second editor that this time edit the same story for a specific style, and then I have the final story. Okay, so I start with these 3 independent agents, but in reality, what I want to do is to have a single agentic system is exposing the API of a single agentic system that internally is made by 3 different agents, but this could be an implementation detail that could be, again, hidden to the final user of this agentic system. The public interface of this agentic system is that it takes the topic, the audience, and the style, and then it returns the story for the topic, edited for the given audience and style. Okay, so this is the API of my agentic system. So what I do is that I just define a method that mocks this API. I have my method that takes these 3 arguments, the topic, the audience, and the style, and then return the story. And then I can invoke this method saying that I want a story about, in my case, dragons and wizards, edited for an audience of young adult, and in the style, in the fantasy style. Okay, so this is how I want to expose my agentic system. So what I do is that what I can do with the LangChain4j agentic framework API is defining my three agents, the creative writer and the audience and style editors. And I do this simply by passing them a model. In this example, I'm passing to them the same LLM, but of course, they could be three different, because maybe you may have some specialized model for a specific task. And then you have an output key, and you will see why. And then I say, okay, I want to create a sequence that has the interface of the story generator that I showed in the former slides that take the topic, the audience and style. And this sequence is a sequence of three sub-agents, which are the agent that I just defined. Okay, so what happens logically is that you call that method with the three argument, and what happens is that, okay, the creative writer did the topic, so it takes the first of these three argument, it generate the story, and then the story together with the audience is passed to the second agent, to the audience editor, that regenerate the story for a given audience, and then that changed story is passed to the style editor together with the style that rewrite the story again, and finally the story is the final output of my agentic system. Okay, so what happens logically is that all this information are passed through from one agent to the other inside this agentic system. What happens in reality, it's simply that this agent have a shared state, and you can think to it simply about a map where I store the topic, the audience, and the style as they have been provided by the user when he calls my method, and then each agent takes the input that it needs for this shared state and also write in the shared state. Okay, so this is what happens in reality. This shared state is in a data structure that I call the agentic scope, because it's indeed the scope of the agentic system. And as we will see, not only it has this shared state, but it also, of course, records all the invocation that have been made during the execution of the agentic system. And its other goal is to provide an agentic system-wide context to each and every agent. I have a demo to demonstrate why this is important later. Okay, let's go quickly through the other available pattern. Of course, you may want to create a loop. So in this example, I'm having another agent that this time provide a score. It scores the given story for a specific style. It returns a value, a double from between 0 and 1. So what I'm doing is that I create this loop between the style scorer and the style editor, and the loop may exit for it has two possible exit conditions. Either I reached a maximum number of iteration, or I met the exit condition that in this example, it means that the score has reached a specific threshold. So in this case, I defined my loop. As you can see so far, each agent has been typed because I'm giving it an interface. In this case, I'm not giving it any interface. So this is an untyped agent. Typically, this is something that you may want to do for internal agents that are not exposed to the end users. And then, okay, I spoke about the exit condition. So the style score generate the score, and this score is used by the loop to check the exit condition. And the other thing that it is interesting here is that you see I'm creating a sequence now where the sequence is made by two agents. The first agent is the creative writer that I had before, but the second agent is not a simple agent, but it's a workflow pattern itself. It's a loop in this case. So this is the way how LangChain4j Agentics allow you to compose all these patterns. All these patterns that you see in this presentation are built-in block, and you can compose them hierarchically in this way. So the loop is made by the star scorer and style editor subagent, and itself it becomes a subagent of the entire sequence. Okay, another couple of very simple example. In some cases, you may want to run this agent in parallel, so you may want to do this. For example, here I want to create an evening planner agent that suggests me a list of evening plan based on a specific mood. So I'm asking to the food expert 3 meals for a romantic evening, and I'm doing the same to the movie expert. I'm asking 3 films for a romantic evening. They work independently and in parallel. And then you have a function to combine, an aggregation function to combine the result of the two agents when they are available. Okay, that's all. And the fourth pattern that you have is indeed the routing. In this other simple example, I'm creating a chatbot made by different experts. So I'm answering to generic question from my user, but this question could be of legal topic or medical or technical one, and then I have 3 different LLM expert of these fields. So what I have is that I have an initial agent that decide what is the topic, and then based on this decision, based on this categorization, the router decided send the user request to one of these 3 experts. So this is quite a real world example, I believe, because for instance, in this case, you may have an LLM that is specialized, that has been trained on a legal corpus, and another LLM that has been trained on a medical knowledge base, and then you want to differentiate and call this expert in this way. Okay, so this is quite a real world use case probably. And then the other, so these are the 4 workflow patterns that I have. But then the other relevant point is that, as I said, I have this agentic scope data structure, and one of the goal of this data structure, other than providing a shared state for the agent, is also providing a shared context for this agent. So let me try to demonstrate this with a simple demo. So here I have the code again of the conditional workflow example. So as you can see here, I'm using a different API, LangChain4j. All the slides of the code that you saw so far in the slides used a programmatic API. I also have a declarative API, a declarative counterpart. The 2 things are totally equivalent, and you can mix the 2 styles. So you can have an agent that is partially declared through annotation, and is partially declared programmatically. Here I'm going through the entirely annotation style, and as I said, I have I have this is my top level agent. So in my chatbot, this is the agent that is injected in my REST endpoint, in my WebSocket in this case. And this agent is made by a sequence of two sub-agents. One is the router that decides the category of the user request. So it may be, as I said, legal, medical, or technical. As you can see here, with LangChain4j agent, you have fully support for typed input and output. So you cannot only work with string and primitive type, but you can really work with any kind of enumeration or POJO. And it's up to LangChain4j to convert the LLM response in the corresponding Java object. So here I'm having, as a first agent in the sequence, this agent that does the categorization. And then my second agent is the conditional agent that routes, that based on the categorization made by the first agent, it routes the user request to the medical agent, to the technical one, or to the legal one. Okay, so let's try to start this and put this at work. I'm starting my Quarkus server here in the mode. And let's see how this works. Okay, should be running. Okay, so here you can see how my chatbot works. Of course, the very first thing that you can notice is that I have no clue on how to do a nice web interface. It's not my work, sorry. But here you can also notice how this agentic system works. So let's try to use this. I can say, for instance, I broke my leg. What should I do? Okay, so you probably have understood already what's happening now. The question is going to the categorization agent that decide that is a medical question, and then the routing forwards this question to the medical expert. Okay, and then I can go on with my conversation. I could ask, for instance, should I assume my neighbor to cause this damage? Okay, and here, of course, it's happening once again exactly the same. This time, the question will go to the legal expert, of course, right? So you have the response of the legal expert now, but if you read this second response, you may notice a problem. This response of the legal expert is totally unaware of what happened before. It is missing the history of this conversation. One thing that I didn't mention is that each and every of this agent, let me show, for instance, the medical one. Each and every of this agent has their own chat memory, yes, but this chat memory is local to the agent. But what's happening now is that this is the very first time that I'm meeting the legal expert. It doesn't have any history. His chat memory is empty, and he knows nothing about what happened in the remaining part of the agentic system. Okay, so this is why LangChain4j allows you to enrich the agent with some context taken from the agentic scope. Okay, so here I'm saying, okay, the context of the legal expert, it's not only its own chat memory, but it's only a summarization of the context taken from the conversation that this agentic system also had with the other two experts. Okay, so here I'm providing an additional context to this legal expert. This context provider is in reality it's a generic function. You can plug the behavior that you want. So in reality, it's just a function that takes the agentic scope and provides the context to the agent. And of course, you have some default implementation of this function. In this implementation that I'm using here, I have something that takes the agentic scope, takes the conversation with the medical and the technical agent from the agentic scope, summarize them, and put and enrich the context of the legal expert with this thing. So let's give a second round to this. So I'm doing exactly the same now. So once again, I can say I broke my leg. What should I do? As you have noticed, I didn't restart the server because I launched Quarkus in dev mode, and I'm using the Quarkus extension. So the change that I made into the code is immediately reflected in my server. So as you can see, same thing as before. Now let me ask again if I should sum a neighbor for my broken leg, and you should see a slightly different reply this time, because now the legal expert has the context. The legal expert knows about the conversation that we had with the medical expert. And that part of the conversation is injected into the context of the legal expert, is injected into the user message that I'm using to call the legal expert. So as you can see now, the legal expert is replying about my neighbor that caused my leg injury. He knows now that I have an injury to my leg. It's no longer a generic question. It's a question that is related with my actual problem. Okay. And another nice thing that you have with the latest version of LangChain4j, just to be clear of how this thing works, you can see here the some information about the agentic system. You can have this report automatically generate for you. The way how you can do this, it's simply that you make your root agent to implement this to extend this monitor agent interface. By simply doing this, all the execution is monitored, and the result of this monitoring can be exposed through this nice HTML static page, where you can see both the topology of the agentic system. So once again, okay, I hope this is now clear. I have a sequence made by my classifier. The classifier generates a category that goes into the router, and the router decides which of the three sub-agent, which of the three experts it should query. Okay, so this is the static topology of the agentic system. And then, of course, you have a diagram demonstrating how the sequence of agents that have been invoked and why. So I have my first interaction when I have a classification, and then I call the medical expert, and in the second one I call the legal expert. Okay. So I hope this clarify why this agentic scoping is important, why having a context that is shared among all the agents in the agentic system is an important feature to have. And then the subsequent step was that, okay, these are the workflow pattern, and then I wanted to give to my agent even more autonomy. I don't want the agent to be wired in a deterministic way, but I wanted another agent that can autonomously take decision and indeed decide which agent it wants to invoke and with which argument. Okay, so I have a very simple an architecture like this. So in this case, I have this supervisor agent. And if you see, I'm doing the same thing, for instance, that I'm doing to the sequence pattern or with the other pattern of the workflow patterns that you saw before. So I am in a root agent and I'm providing the agent A, B, and C to it. Okay, so but this time I'm not saying invokes A, B, and C in a sequence. I'm telling to the supervisor, your sub-agent are A, B, and C, which are capable of taking some action, of doing some specific work. And then it's up to you to decide how and when to invoke them. So in reality, what this other LLM does is returning a teach being invoked multiple times, and at each iteration it returns this agent invocation, which it is just the specification of the next agent to be invoked with the agent name and the arguments. That's all. Okay. So, okay, this is an extract of the system message of this agent that I have internally. What I wanted you to notice here is that, of course, you need to have a definition of done, because at some point the supervisor have to decide, okay, I'm finished. I don't have any other agent to invoke. I'm done with this. And then I'm passing to this agent also a description of each of the sub-agent together that with the argument it takes. So the description is just a string describing indeed what the argument does, plus the list of arguments that are necessary to invoke that agent, and that list of argument, of course, is automatically inferred from the signature of the agent. And okay, and the message that I used for the supervisor can be further customized. And then, okay, this is probably a lower level implementation detail, but I have another agent that also decide which is the response that you may want to finally give to the user. Because what happens in reality is that you invoke this agent in a loop, and then at some point the planner decided that it's done, and then you have to return the input. But in some case, you want to return the very last response of the last invoked agent. For instance, in the example of the creative writer, you have the creative writer creating the story, and then you have the two editor editing it, and then you want to simply return the final story. You don't want the whole history of what happened during the execution of the agentic system. In some other cases, like the one in the next example, you will see that you may want to have a summary. So I have another agent that is simply a score. It takes the two possible answers and decide which is the more appropriate answer to give to the user based on the user request. But of course, this is optional. You can skip it. In many cases, you already know that you always want the summary, or you always want the last response. So you just tell this to the supervisor. Okay. So let me give you a practical example also of how this works. I have my three agent. A first agent this agent acts on bank account denominated in US dollars. So the first agent withdraw US dollar from a given user. The second agent can credit dollar to another user. And then I have a third agent that calculates the exchange rates between two currencies. Okay. So what I'm doing is that I'm defining these three agents, and then I'm giving these three agents to the supervisor in exactly the same way as I did to the sequence, for instance. Right? So once again, this is to say that you can compose. This is another building block. You can compose this thing. One of the sub-agent here could be not a single agent, but could be a loop, could be a sequence, could be a router, whatever you want. Okay, so you can really compose this building block in a hierarchical way and orthogonal way. So what happens is that, for instance, I'm trying to put this agent at work. I'm saying, okay, transfer 100 euro from my account to one of my friend Kevin, and this is the answer. Okay, so the answer is 100 euro are equal to 115 US dollars, and then the new balance of Kevin is $1,115, and my new balance is 885. Okay. And how this works internally, as I said, the supervisor generates this sequence of agent invocation. So it first decided that it needs to figure out how many dollars are equivalent to 100 euros. So it calls the exchange agent, passing to it the original currency, the euro, the amount, and the target currency. And then the exchange agent replies that it is $115, and then it gives that amount of money to the Kevin's account and withdraw the same amount of money to my account. And then the fourth invocation is that definition of done. It says, okay, I'm finished, and it returns with the summary of all the action taken. This is the case when you want, of course, a summary of all the action taken during this complex interaction. Okay, so this is what I have, and then Rory created this very nice application to showcase all the patterns that I discussed so far, and I'm passing the stage to him so he can show in better details how this app works. Thanks. You are mute, Rory.
Thank you so much, Mario. And I also the LangChain for Beginners training. We put the link on the bottom though. And one of the things that I did is I showcased from just prompts all the way through to MCP tooling and then agents. And one of the things I didn't understand, I read your incredible agentic module, but I didn't understand how to code it. And I wanted to go through that process to code it. So I created the Agentic Patterns showcase. You can access it. Everyone has access to it. It's hosted on Azure, and it's aka.ms/agent-patterns-quarkus. And if I click on that, you'll see there that it's actually connecting to a WebSocket, and that WebSocket there uses the agent listener. And all the workflow patterns that Mario just defined, from sequential, parallel, loop, and conditional, and also supervisor. And in addition, that the human and also the goal-orientated and peer-to-peer, that it's the more advanced patterns. But if you go into here, and Mario just covered supervisor agent, transfer $100 tomorrow to Georgios, and then convert $50 to euro. And I hit execute pattern here. You see, it's going to take your bank supervisor, your withdrawal agent, credit agent, and exchange agent. And like Mario said, it's going to classify it. So you're going to get there. Sorry, not classified. That's conditional. You're going to call the tooling, the withdraw tooling, and you can access that if you go into the source repo, and the source repo, let's go into Supervisor here, you'll see there that it actually has the tools there, the withdraw tools, the bank tools, the exchange tools, and it's going to run with the summary agent there, and it's going to run through that though. So this is located, and let's just give you a little summary here. So let's go into that. You can access the code here from current slide. You can access the agent patterns -Quarkus, and then the repo is the github.com roryp/matrix agents. I just wanted to show you that. Let's go back to the agent showcase, and let's see if it's finished. There we go. It's finished there. It took 31 seconds, round tripped for a few agents though, and it gets you the result. And I want to hand it back over to you, Mario, to complete your presentation.
Thanks. So yes, so up to this point, this is what I had when I did the DevOps Belgium in October. And then I had a lot of conversation with people there, which is the reason why I love to go to conferences, especially to DevOps. And I had lots of feedback of people asking, okay, but I have this very specific use case, this very specific need of orchestrating agents that are not provided by LangChain4j. Can you please implement it for me? So when I went back to home, I thought, okay, I cannot foresee all possible needs, and for sure there cannot be a sites that fit all the needs. So what I want to do is to provide people to create, to define their own agent orchestrator pattern. I wanted to have this planner, which is indeed something that decide the sequence of agent to be called in a pluggable way. I want people to plug their own planner. Okay, and then of course, so I have this. You can plug your own planner, and then this new planner becomes part of the agentic framework, and it runs together with the other pattern on the execution layer that in my example is provided by Quarkus, but of course is also customizable. Okay, so what I did is that defined the simplest and most generic possible interface. With this interface, okay, the only method that you really have to implement is the next section. Okay, the next section just say, given the current context of execution, tell me what is the next action to be taken, where an action can be simply invoke one or more agent. When if you say more agent, it implicitly means you are invoking them in parallel. Invoke one or more agent, or I'm finished, I'm done. Okay, and optionally you can implement the initialization method that normally you have to implement as well. And I separated the first and the next action just because in many cases in the first action you want to take some it's just convenient. You may want to take on the very first action some other initialization code. Okay, but by default first action just fall back on the next action method, as you can see. Okay, so once I have introduced this planner abstraction, then of course the first thing that I did was let's say dog fooding. I wanted to re-implement all the pattern that I have in terms of this abstraction. Okay, and it's very nice and interesting to see how it works. For instance, this is probably the simplest planner implementation of this planner abstraction. This recreate the sequential pattern. So during the initialization, it just records the list of sub-agent for this sequence. And then what it does in the next action is just I just have a cursor to say which is the agent that I have invoked last time. So in the next action, I simply say, okay, if I have a next action, a next agent to be called, it will be the next one in the list, and I increment my cursor. And if I reached the end of the list, then I don't have anything else to do, and I can simply return done. Okay, so this is the re-implementation of the sequential workflow in terms of this planner abstraction. So the way I use this thing is that instead of saying give me a sequential builder, I say give me a planner builder. So it now expects an implementation of the planner interface. In reality, it doesn't expect the implementation, but it expects a supplier of that implementation, because at each execution of the agentic time, he has to reinstantiate the planner and reinitialize it, of course. So what you said is that, okay, create, this is totally equivalent to have a sequence workflow of the creative writer and style editor. Okay, but this time I'm using explicitly the sequential planner. Okay, so this is just to demonstrate how I implemented all the patterns that I discussed so far in terms of this planner abstraction. And then, of course, I wanted to implement more patterns. So, for instance, this goal pattern, goal-oriented pattern, is also something that you can find in Rory Agentic Showcase. So you can experiment with it as well. How this thing does? This is a new pattern that I introduced using this planner abstraction. What it does is that in the initial step, it is, I want to invoke the sequence of agent in a goal-oriented sequence, meaning that I have each agent has its own input with if you think about it, the precondition of the agent, and the output of the agent is the post-condition. So the goal of the entire agentic pattern is the output of the entire agentic system. This is the goal, okay? And then, given the sub-agent with their own input and output, I can create a graph of dependency of this agent, okay? Then in the first action, what I do is that I need to start from a given precondition. And in this case, the precondition, of course, is the input provided by the user. So by checking the input provided by the user, I know which is the precondition. And now I have the starting point, which is again the precondition, and I have the goal. So I can calculate using this graph, this shortest path from the precondition to the goal. And then at this point, I have a sequence of agents to be called. So the next agent, if you look into it, it simply implements exactly what the sequence agent, the sequence pattern does. Okay. So to give you a practical example, I have these 5 independent agents. One that takes a prompt and extracts a person. The other extracts the zodiac sign of that person, and one other that creates an horoscope, and so on. Okay, so when I create this goal-oriented pattern, I tell it, okay, your output is the write-up, the final write-up, the final horoscope that I want to present to my user. So that output becomes the final goal of the goal-oriented planner. And then I have my 5 sub-agents that are not invoked in the sequence that you see there, but are invoked in the sequence of the determined by the goal-oriented graph, right? And then I say, okay, your planner is the goal-oriented planner. So what happens is that when the user sends the prompt, now I know that the precondition is the prompt. I know that the final call is the write up. Given the input and the output, I can create this goal-oriented graph of dependencies. And so I can invoke my agent one after the other, following the graph from the precondition to the final call. Okay, so I'm not telling, again, to this thing, invoke this agent in a sequence, but determine your the sequence in a goal-oriented way. Okay, and once again, if you think about it, this could be a nice solution for many cases. But the beauty of LangChain4j is once again that you can combine this new pattern that we just invented with all the existing one. So, for instance, one thing that I could realize while using this is that structurally I cannot have loops in this execution, because by definition this is calculating the shortest path in a graph, and the shortest path doesn't have a loop. But I may want to have a review loop at some point. For instance, at the end of this thing, I may want to have a review loop. So what I could do is that I could replace the final writer with a loop pattern, and use this loop pattern as one of the agents inside my goal-oriented feed. Okay, so still, this is to say that I can combine all these building blocks, both the one provided out of the box of LangChain4j and the one that you may want to create in the most flexible way. Okay, so this is all I have about this agentic pattern. And then if you look into the other feature that I have, okay, I have the error handling. It is possible to have a non-AI agent. For instance, if you think about it in the exchange, in the bug example, you don't really need an LLM-based exchange agent. What you may want to do is to simply call a REST API that gives you the exchange rate, right? So having an LLM in the middle there is something not really useful. You want to have a non-AI agent for that specific task, but you may want to mix that non-AI agent with AI-based agent in the whole agentic system, and you can do this seamless with LangChain4j. A specific implementation on non-AI agent, of course, is the human in the loop, which is also something that is demonstrated in Rory agentic showcase. The human in the loop is simply a thing that stops the execution and wait for the human input before moving forward. So this is very typical again in an agentic system. And then you may want to have some agent that you can optionally declare that an agent is asynchronous. You may want to do this because you don't want to wait for a result before moving forward. Suppose you have a sequence of 3 agents, okay? But the second doesn't need the output of the first before being executing. So if you declare that the first is asynchronous, it is executed on a different thread. And so the second one doesn't have to wait for it because it doesn't need its input. And then maybe the third one needs the output of the first one. So it either at that point, either the result is available and it will take it. Otherwise, only the agent that needs really the outcome of the asynchronous agent will be blocked waiting for it. Okay, and then of course we have A2A integration with the latest release of LangChain4j. We also added MCP integration, so with A2A you can have a remote agent. With MCP you can have a tool which is as you can imagine in this case modeled as a non-AI remote agent. And as you can see, as you saw, you both have the programmatic and declarative API that are fully interchangeable. And if you use the Declarative API and the Quarkus extension, you also have CDI support, so you can inject your agent in the other part of your application. And yes, there is much more. As you saw in the latest release, I also added that monitoring that gives you a nice HTML representation of the this thing, a nice HTML representation of the agentic system topology and execution. This is to say that we are still improving. This is still a huge work in progress. We are still adding features. So if you are interested in this work and if you feel that something is missing, please get in touch with me and open a issue on GitHub, or let's chat on Slack. I mean, we can find a way to exchange idea and make this thing as powerful and compelling as possible. And that's really all I have. Thank you.
Thank you so much, Mario. And it was, wow, just an incredible eye-opener to see the story behind it and then also the implementation. I want to thank you for your time. I want to thank you for the reactor. This is number 6 of 6 sessions, though. We've taken all the way from starting with the project introduction, all the way through to tools, MCP, prompt engineering. We had best practices by Brian Benz, and we're finishing off the bonus finale with Mario about the agentic patterns. I want to thank the reactor time. I want to thank Mario, and I'm going to say goodbye, everyone, and thank you. And I look forward to seeing you in more of the reactor sessions. Bye.
Bye. Thanks a lot for your time. Bye.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.